Hey guys, welcome back. So today we're working on this GP5500. This one I found on Facebook Marketplace. It was given away for free. According to the person giving it away, it ran great last year, but there's water in the tank, and this machine is for parts or scrap. The person giving away said nothing about repair. So, of course, my hope is that I can repair it. But I've got to say, it was in pretty bad shape when I picked it up. It was sitting in a puddle of mud. It was covered in mud. So I actually gave it a good pressure washing before bringing it in, which I usually don't do on generators, but sometimes you just have to. Anyway, cleaned up really well. There's really not a whole lot of rust on the machine. But when looking in the tank, I would say maybe there was water in there, but I think the bigger problem is that there's a lot of bad fuel in that tank. It smells terrible. So yeah, this machine definitely wasn't running last year. I'd say more like 10 years, but yeah, for free, I can't really complain. Anyway, I haven't done anything to this other than look in the tank. I haven't pulled the engine over, haven't even checked the oil. So let me get you set up a little bit better and get going on this. Let's start by checking the oil. The tank problem we're going to ignore for now. And well, that's not a good sign. It seems to be pretty dry. I was worried there could be water in the engine, given the way the tank looks, but now I'm more concerned that there's no oil. So let's pull the plug, see if there's anything in there. Plug's not even tight. So maybe it was drained. Yeah, it must have been drained. Why, I am not sure. But definitely not a good sign. So I think the big question here is the engine stuck? Nope. And there is compression. So yeah, it should run. I wouldn't say the compression feels great though. It kind of has high leak down. So maybe that'll get better once it runs. Potentially we need to adjust the valves. But this should run the way that it is. So let me get some oil back into this engine before moving on. I'm noticing the fuel valve, it is in the off position, so there's a chance, although be it slight, that the carb might be in good condition. So we will check that out in a minute, but for now I'm thinking let's just get the tank off the machine. It's kind of in the way. We're going to have to take it off anyway at some point to deal with the mess that's inside. So we will get the bolts out. There's one in each corner, and I'm going to cut this line off because it is petrified and needs to be replaced anyway. All right, let's take a look. I'm going to pull the drain, see if there's anything in that bowl. And yeah, it looks like water with a bit of rust. Don't think there's any fuel in there, so the carb is, I would say, in pretty bad shape. If you look at the bolt, you can see also some rust and varnish there, and the smell, it's pretty bad. So yeah, this generator's been sitting around for some time, I'd say. So without doubt, that carb's gonna have to be cleaned up or replaced. But I'm thinking, let's just check the valves real quick. We definitely had compression. The leak down was high. I'm thinking that'll go away once this engine is run. It's likely been sitting around a long time, but it can't hurt to check the clearance. So right now, the intake is open, and the exhaust feels like it's almost at zero clearance. So that would definitely explain the leak down, because during the compression stroke, the decompression system, it bumps the exhaust. And with it this tight, it might just be leaking out if the valve isn't fully closed. But even if it is fully closed, that decompression system is going to give the valve an extra bump, letting too much compression out. So let me get the feeler gauges out, and we'll just see where each valve is at and adjust as needed. So since the intake is open, we can check the exhaust. The spec on this engine is 0.008 of an inch, plus or minus 1/1000th. And an 8 does not fit. So let's try a 6. 6 does not fit either, so we are out of spec. 5 does not fit. And a 4 almost fits, so we are likely at 0.003 of an inch, which we are, so that's too tight. That should be 0.008. I'm going to rotate the engine till the exhaust opens, and then we'll check the intake. And the intake should be at 0.006 plus or minus an inch. And I can tell we do have a better gap here than we did on the exhaust. So the 6 fits just fine. So let's try a 7, which would still be in spec. And a 7 fits. It has a good amount of drag. And an 8 is quite tight. So the intake, I think, is fine, but we do need to adjust that exhaust. So I'm going to rotate the engine again until the intake's open. We'll crack this loose and make the adjustment. So I am going to set this at 0.009, which is on the high side of the spec, but usually when you tighten up this jam nut, that clearance will decrease by up to a couple thousand. So we might end up closer to 7 when we're done. So that feels good right there. And yeah, we're already tight. So the jam nut, I didn't tighten it much, so I can still kind of fine tune it. So that is a tight 0.009. So let's snug that up all the way and see where we're at. Yeah, so a 9 is too tight. Let's try a 7. And a 7's also too tight. So we do need to open up that gap. All right, a 9 feels pretty good. So I'm going to snug this up a bit and just kind of check it along the way, because as you tighten the jam nut, it takes out the slop in the threads, and that clearance changes a little bit as you tighten it. So a 9 is too tight. So we'll back this off a bit. There we go. Jam nut's all tight. Let's check the 8. 8 fits. It has a lot of drag. So it's probably closer to a 7.5. Let's just check with the 7. Yeah, the 7 fits just fine. So the exhaust valve should be good. Let's pull the engine over, see if the leak down feels any better. Yeah, that is a noticeable improvement. So the leak down, it isn't quite as aggressive as it was. So making that adjustment definitely helped. And, we needed to do it anyway. That exhaust valve was, getting a little bit tight at 3 thousandths. It wouldn't have been much longer before the engine lost compression due to a tight valve. So now everything's been reset and shouldn't need any adjusting for a while. Anyway, I think fuel here is going to be the big issue, given what is in the tank, what came out of the bowl. I'm also noticing, too, the fuel filter is kind of cracked and destroyed. So, yeah, let's dig into the carburetor. We're going to have to if we want to hear this thing run. Noticing the cover's on upside down. The air intake should be down here at the bottom. So like that, I guess technically it would still work. Kind of. Anyway, it's got a filter. Seems to be in good condition. So that's a good sign. I'm noticing this carburetor is not the original one because the fuel solenoid is not plugged into anything. So, that's fine. You don't have to use it. The position is normally open. But it just says that someone's been in here and replaced this at some point. And it might have been recently because the nuts were pretty loose. And the carburetor usually sticks to the gasket, but in this case, it just came right off. So potentially, whatever rust and debris that's in there might be fairly recent. All right, place your bets. And I think it's going to be a mess in there, but I'm thinking someone replaced this carb kind of as a last-ditch effort before giving this away. So it may not have been installed for too long. Yep, the pin is not stuck on the fuel solenoid. And the bolt covered in a lot of junk, but actually not rust. So that should clean up. Bowl full of junk, but the bowl itself isn't rusted, so that should also clean up. And it's not terrible in here. The needle is not stuck. Pin is not stuck. And the main jet completely clogged. So that that might have to soak in the ultrasonic before it'll come out, but let's try it real quick. Yeah, it's coming out. There's the main jet covered in mud, and the emulsion tube might need a little bit of help. Yeah, kind of the same story, just covered in junk, but the tube itself will clean up. And last but not least, we have the pilot circuit. So let's get that out. Then we'll just go through all the passages, clean this up as best we can before putting it in the ultrasonic, and then we'll let it soak for 5 or 10 minutes. And I think this carb's going to be in pretty good shape. Although, as I was saying that, I'm just looking at the needle, and the point looks a little bit deformed. It should be a fairly uniform cone, and it looks like the tip is squeezed pretty tight. So the needle, I would say, should be replaced, but the rest of it should clean up pretty well. Okay, that's pretty much it. So yeah, we'll spend a few minutes just cleaning up the parts the best we can, and then we'll let the ultrasonic do the rest. I'm noticing the bottom seal on the pilot jet. It seems to be distorted. And like that, it's going to create a vacuum leak. So it may not be able to pull fuel properly through this bottom hole here. So like that, the generator will surge. So that seal has to be replaced, or potentially just the whole pilot jet swapped out. So you don't want to get carb spray on the neoprene parts like the bowl seal or the needle, because a lot of carb cleaners like this will actually distort the neoprene, causes it to swell, and then you have other problems. This one also has a removable pilot needle. So I'm going to turn it in and just see how many turns we're at. So we'll set it back to the same. So that's 1.5, 2, 2.5, 3. So that actually is kind of a little bit far out. I think closer to 2 turns would be a better starting point. All things considered, it cleaned up pretty well. Now the bowl, it's not perfect. There is some corrosion. We know we have issues with the seal on here as well as the needle. And this actually has a fair amount of corrosion. So, although I think some of this could be used, I do have a parts carb that, is actually in very good shape internally. The issue with this carb is more the throat of the carb. It's just all carboned up. So this, as far as I'm concerned, is a parts carb. And I'm thinking of actually just swapping the entire bowl as well as the bolt, because this is spotless. The bowl is in excellent condition. And this one doesn't have a fuel solenoid, which is perfect because this generator can't power a fuel solenoid. So we're also going to steal the float with the needle and also the pilot jet. So we'll start by just getting the main jet and the emulsion tube back in. As well as the bowl seal. So we'll just lightly bottom this needle out. Then I'm going to back it out 2 turns. There's 1, 2. And this is the idle set screw. This generator does not idle, but it does hold the pilot jet in, so you do need the idle set screw, but only turn it until a thread or 2 pokes out the other side. And that should be it. So let's get this reinstalled and try it out. Gonna leave the airbox off for now. So it could run a touch lean, but usually these engines run pretty well with or without the airbox. So, I don't want to commit. This carb is in pretty bad shape, so although it looks clean, if there is a clogged passage, then we may need to swap this out. Needle and seat, they seem to be working, so let's give this a try. So now is the time where we find out if we have a viable machine or if this is a parts machine. So the carb, it is filled up with fuel. I've got a light plugged in and turned on, and I've also got the kilowatt plugged in as well. So let's turn the ignition on, choke on. Let's see what we get. There is good news and there is bad news. Let's start with the good. The engine, it started first pull. The engine sounded great, and the carburetor is running the engine quite well. Now, it did shoot out a little bit of debris, so we do need to pull off the blower housing and just clean that out. But more importantly, the generator does not seem to be working. That light did not turn on, the kilowatt did not illuminate, and, the engine sounded a little bit slow, so I did bump the throttle a bit just to get some speed up to see if that would make a difference. And unfortunately, we are not making power, so we do have issues with that generator. So I'm going to turn the machine around. I think we're going to get the end cover off. We'll do a quick visual. And if there's nothing obvious, then we will run some tests, see if we can't get to the bottom of the problem. It's hard to see because there is a lot of stuff in the way, but from what I can see, the stator looks to be pretty good. I don't see any burn marks. The lacing is not melted or broken. So yeah, this one I would say has a chance. If we're lucky, it is a bad AVR or a bad set of brushes. The alternative would be a bad stator or bad rotor. So let's get the AVR and the brushes out of the way. We need to disconnect all the wires. That'll give us a better view of everything and also allow us to test each winding individually for a fault. So visually, the brushes look to be in good shape. I was kind of hoping they would be broken, because the new set of brushes only costs about $1. Yeah, it looks like we have two sets of white wires. And I assume they're both neutral, but manufacturers sometimes do funny things with wire colors, so I'm not going to take any chances. I want to make sure this set of whites go back right here. Then we have red, gray, and white at the top. All right, so let's run a few checks here using the multimeter. Now, you do need a meter that can measure resistance, and before you check anything down here, check what the resistance is of your leads, because some meters, that resistance can be pretty high, and the values we're testing here are pretty low, so you want to know what the resistance is in your leads. In my case, it's 0.1 ohms, so any measurement I take down here, I can subtract that to get the true value. Anyway, we do have clues here as far as what the problem is. The generator did nothing. We had no power output, but the engine also didn't go under load, and there was no smoke and no fire. So, that tells me that the rotor, which is what spins in the middle, didn't power up. That is an electromagnet, if that powered up, something should have happened. Either everything runs normally or we get a meltdown. And since we got neither, I'm pretty sure that rotor did not even try to power up. So either the rotor is bad or its power source is bad. You know, the power comes from the DPE winding, which in this case are these blue wires, and that's AC going into the AVR, gets rectified to DC and then sent to the brushes. So we could have a bad DPE winding, could have a bad AVR or set of brushes, but yeah, usually it's the rotor. So I'm going to go out on a limb here and say that the rotor is bad. I've been getting a lot of machines with bad rotors, and most of those were stored outdoors like this one. So I think, you know, that has something to do with it. Anyway, let's start with the DPE winding. Usually these come in at 1.5 ohms, but there's a pretty big range. 1 ohm all the way up to 3 is pretty normal. In this case, we're at 3.5, so a little bit out of range from what I normally see, but it's pretty close. No ground fault and no insulation failure to the other legs in the stator. So the excitation, which is the power for the AVR, seems to be good. The next thing in line is the AVR, which is kind of hard to test, so usually I just eliminate everything else. And if everything has been eliminated, then it must be the AVR that's bad. You know, in this case, we're going to skip that. We could test the brushes next. I'm thinking let's just go right to the slip rings. You know, a lot of these failures recently are on the rotor. So I'm going to put one lead on one slip ring. We'll check it to ground. No issues to ground. And let me put the leads on both slip rings, on different ones. And we should get between 40 and 70 ohms on a Honda clone. And in this case, we have open circuit. So yeah, the rotor is the problem here. And it's not to say we don't have other problems, but with the rotor being the way that it is, you know, this thing is never going to make power. So yeah, let's just check the stator to see if that's any good before we pull this apart. So leg 1 usually between 0.2 and 0.5 ohms. In this case it's pretty high, but there is corrosion on here, so let's try a different spot. There we go. 0.4 seems good. We'll check that to ground. No fault to ground. We'll check it to leg 2. There shouldn't be any connection there, and there isn't. So let's check leg 2. We want to see about the same, 0.4. And again, pretty high value, but there is corrosion here, so let's try a different spot. Yeah, 0.3. So a little bit lower. You know, ideally these should be matched, but they are, yeah, they are very close. So I think leg 1 and leg 2 are fine. Let's just check leg 2 for a ground fault. No issues there. And the excitation, we can check that for an insulation failure to leg 1 and leg 2. And that seems to be fine. So the stator actually seems to be good. The issue is the rotor. So let's get the stator off. That'll give us better access to the rotor, and potentially we can identify and fix whatever the problem is. Before we pull the stator off, we actually have to pull the exhaust off. This bracket right here is for the exhaust, and it's preventing the removal of the stator. So we need to get these two bolts out, the two attached to the engine, and this should just come right out, and then we can focus in on removing the stator. Definitely need to pull that blower housing that's just packed with stuff. I don't need to remove these wires from the block because when I remove the stator, the wires will come with it as well as the end housing. But I do need to remove these mounting bolts so I can get it kind of out of the way so I can get a 3-jaw puller in there to pull this end housing off the ball bearing. So with the 3-jaw puller, I mean, technically a 2-jaw puller would work better, but you do want to distribute the force because this end housing, it is quite weak. And if you're only pulling on 2 points instead of 3, it's just that much more likely to break. So when you put it on the end housing here, you don't want to put one of these jaws where the brushes go because that is thinner than everywhere else, and that will crack first. And don't put much force on this. If it doesn't come off right away, and I can tell it is because of the noise it's making, the laminations as they come out. But if it's not coming out, just stop. You know, try a little bit more PB Blaster down by the ball bearing. You know, sometimes a soft rubber mallet, just striking it around here will help free it from the bell housing. So I've got you in here real nice and close. You can see right there, that's one of the wires that connects to the rotor. And it is soldered on to this tab, which connects over to the slip ring. So a lot of times these break loose and they'll actually move around. In this case, that one's not moving, but there does seem to be a fair amount of corrosion. So potentially it's just a corrosion issue instead of a broken wire. Let's check the other one. So this one seems attached a little bit better. And the wire seems to be attached. So right at that connection, that's usually where they break. There's also sometimes a connection, between these halves. And I think you can see there is kind of right in there. Just the two halves twisted together. And that actually might be it. That's moving really easily. Yeah, I think that's it. So there's one wire here which is attached, and then I think there's another one in here somewhere. So let me pick at this a minute, see if I can find the other half of this wire. And there it is. So the good news is we do have a little bit of slack. It's wrapped around here. The bad news is, despite the color, this wire, it's actually aluminum and it's just copper clad. So there's a very thin coating of copper on the outside to help solder them together. So there is a chance we could reconnect these. In theory, if it was copper, it would be really straightforward. Since it's not really copper, that could be a problem. And the aluminum tends to crumble, so if I bend this wire too much, it's likely just to break again, and then we don't have anything left to connect. So let me spend a minute. We'll unwrap this as much as we can. We're probably going to have to reinforce this with some sort of epoxy to help it stay still, because we're not going to have anything left wrapped around there. But I think this one has a chance. And the other thing to consider here too is that this is magnet wire. There is a layer of varnish or enamel on this wire. So even though I'm twisting them together, it's not actually making an electrical connection. But if you heat it up sufficiently when soldering, it should burn it off and form a good connection. Yeah, still no connection. So the varnish, not able to burn off. And the solder is also not sticking. I'm not having a whole lot of luck getting the enamel off these wires, never mind connecting the wires together. You know, I've tried heat to burn it off, which didn't work. I tried an open flame. That seemed to work, but when I checked continuity from one point on the wire to another point, there's nothing. So I'm going to try scraping it, which is not ideal. You know, I don't want to wiggle this wire too much. It's likely already weakened. You know, it broke already once, and it's made out of aluminum, which doesn't take much to break. So, you know, I would say odds are this is not repairable, at least not with my skill set, but I'm going to keep going until either it's fixed or I break the wire even more. So the enamel is off, and I'm going to try to solder it again, but I think I'm going to have to buy the proper solder to attach this since it is not copper. Yeah, still nothing at the slip rings. Okay, we're making progress. We got continuity at the slip rings. Although it's still a little high. We're currently at 80 ohms. Ideally, it would be below 70. So I just wanted to show you real quick. We do have a connection, 79.4 ohms. So you would think that's good. And, you know, if this thing didn't spin at 3,600 RPM, you know, it would probably be okay. But the fact is, there's a lot of force, there's a lot of vibration, and this is not connected very well. So I am going to disconnect these wires. And although I could order a specialized flux and solder to attempt to attach these aluminum wires, I'm thinking, you know, let's just clean them up. Instead, we will use a mechanical connection, and then this whole area needs to be glued in place, probably with some sort of epoxy just to help keep the wires still. And of course, the crimp is going to add weight, which will cause a failure, you know, if things aren't secured. So yeah, I'll try to get the wires apart. Hopefully they don't break. Clean them up one more time, and then try crimping them together. All right, best connection yet, 78 ohms, and that's just twisted together. And there is a mechanical connection just by twisting them. And we'll put a little metal piece to crimp those tight. And I think that'll work, assuming I can get the crimper in there. Wouldn't call it pretty, but it is a solid connection. I don't think that's going anywhere. Still have a nice low connection, 78.4. So this should work, but we do need to cement this in place. You know, this is just going to wiggle with this increased weight. So I'm going to bend this back. Hopefully we don't break anything. And then just glue it down. Yeah, at best, I would classify this as a hack. And one that I actually feel better about than soldering. You know, the way these were attached originally, the support was pretty poor. And by folding the wire down and gluing it in place, this is going to hold up, I think, a lot better than it did originally. Yeah, I wouldn't call this the best repair I've ever done, but for better or worse, it is done. And I think it's for the better. You know, originally there was very little relief, you know, from vibration and stress. And now we have a good mechanical connection. We have a fairly low resistance connection. And with the JB Weld in there, you know, those wires cannot move. They cannot vibrate. So we should not have another failure right there. So I think this will power up and it should last a long time. So we need to give this 24 hours to cure at least, and then we'll get this together and try it out. So since we have some extra time, you know, let's spin this thing around. We'll get the blower housing off and evict that critter. Yeah, it looks like most of it already got blown out, but we do have a bit of debris left over there. So we'll get that cleaned up, throw the cover back on. Well, it's been 12 hours and the JB Weld is set up quite well. Not cured yet. We need to wait, I'd say, at least another 12 hours. But, you know, it's good enough that we can at least get this machine fully back together and ready for action. So let's get the stator reinstalled. We'll reconnect all the wires. And in another 12 hours, we'll give it a try. An important step here now is to pull the spark plug so there's no compression, and then pull the engine over. You want to make sure it rotates freely, that you don't hear any scraping or even worse, binding. You know, if that happens, that indicates there's a misalignment, and you need to pull the stator off again and reseat it until things spin freely. Good. The engine rotates without issue. There's no binding, no scraping, so we are good to proceed. Yeah, the plug that came out wasn't in terrible condition, but I wouldn't say it's in great condition either. There is a bit of buildup, a little bit of rust on the plug. So this number here, it's an F7TC, which is actually a torch plug number. And I don't have that exact replacement, but I do have this one, which is a BP6E. So like this, it is a non-resistor plug. And this one might be one temperature range hotter. But I think that should be fine. You know, I've checked the gap. We're right at 30,000. So let's get the plug back in, as well as that heat shield. Well, it's been 48 hours. The JB Weld is nice and cured. So we're going to do the same test as last time, but hopefully a different result. Ignition's on, choke's on, and the light hopefully will come on. Nice. The Band-Aid seems to be working because this time that light came on. We were at 126 volts and the engine speed was a little bit slow at 57 Hertz. So we do need to make an adjustment to the governor spring. So I'm going to start it. We'll make a quick adjustment and get it closer to where it should be, which is 61.5 Hertz. We'll make a little adjustment now while the engine's off, and we'll fine tune it when it's running. But I think the final adjustment is going to have to be outside because I can't run the engine too long inside, even with ventilation. But we can get it a lot closer than it is now. All right, choke on, ignition on. And that's all it needed, was a little more spring tension. So now that we've made that adjustment, we are much closer to 61.5 Hertz. So at this point, I think we're safe to move on. We need to get that airbox reinstalled and then move on and fix up the tank. Uh-oh. That one, it's not tightening up. So hopefully it's the nut and not the stud. I'll try a different nut. far as the tank goes, I think I have one that's in better condition. You know, it's not perfect, and I'm not even sure it fits, so we're gonna have to test fit it. Regardless though, the old fuel in this tank has to be drained. You can see it's in pretty bad shape, so I'm gonna pour a little bit into an open container so you can just kind of see what we're dealing with, and then the rest is going straight into the hazardous waste collection. Oh, that is terrible. So what's coming out right now, I would just classify as water mixed with rust and a tiny bit of fuel. So there's actually a fair amount in here. And I just wanted to show you how bad the fuel was. Can't even call it fuel. So yeah, let me get the rest of that in the hazardous waste collection, and we'll take a look at the other tank I have, see if it's any better. Can't even get the fuel out. It's not clogged, but as soon as you tip it, I think it's just a bunch of rust kind of gets in the way. Huh. This might be one of the worst tanks I've ever drained. It just doesn't want to come out. Now that the fuel is out, you can kind of get a better look at what we're dealing with in this tank. You know, it's not in very good condition. You know, could it be cleaned? It could. But in my case, I do have a couple other tanks that are not perfect, but they're a much better starting point. You know, as far as how this tank got this way, I mean, obviously it was left outside and rainwater got in. But with the design of the cap, there's really no way for rainwater to get in. It's just going to shed off the side and then come right off the side of the tank. The issue, I think, is with the fuel gauge. You know, this is almost acting like a funnel. And if this seal isn't perfect, then it's going to let water in. And when the machine's running, it's actually going to let fuel out, which could theoretically start a fire. So you want to keep an eye on this gauge. And this one, you can clearly see the seal is no good. So the tank we're going to use actually came off a GP5500. I think they're the same tank. So I'm going to test fit it real quick before trying to clean this one up. But as you can see, though, although there is some rust in there, there's not a lot. I mean, this tank is pretty much usable as is. But the evaporust should make it a lot better. Unfortunately, we do have the same gauge, and this one's a little bit loose. So I'm thinking we should replace that seal. This also has a tank vent, and these loosen up all the time. Thankfully, this one is nice and tight, so that should be fine. We'll get a new one of these ordered up, and while we wait for that, we'll just get this cleaned up. The good news is all the holes align on both sides of the tank, so it seems to be a good fit, but it's not quite the same tank. This is actually a higher capacity tank, and because of that, it actually extends further down by 1/2 inch, which doesn't seem like a big deal, but that means the tank is that much closer to the HUD engine and the HUD exhaust and potentially could lead to a problem. Not to mention the tank actually is physically contacting that adjustment screw right there for the governor. So yeah, we do need to make some adjustments here. I'm thinking the easiest thing to do would just be to shim this up by about 1/2 inch by adding a spacer. The other thing we could do is actually move the rails up by at least the same. So I'm going to give that one some thought, but for now, let's just get the evaporust in there and we'll get this part ordered up. And when it arrives, we'll figure out what we're going to do about this problem. Well, it's been a few days, and the tank, it's as clean as it's going to get. It actually did most of the cleanup within the first 12 hours, but I thought I'd give it a little bit more time since I was waiting on the new fuel gauge. Anyway, the gauge is here, so let's get the evaporust out. We will dry the tank and get that new gauge installed. Just going to use a bit of alcohol to kind of soak up what evaporust is left. And we'll drain that out, and then just blow some compressed air in there. You know, the alcohol, it'll evaporate quite fast, kind of minimizing the chance of any flash rust. Usually these are hard to get out because they should be a tight fit, but this one, definitely not a tight fit. I think we're missing something. There should be a float. So I think I heard something kind of rattling around in there. Let me see if I can find it and fish it out. Well, the tank, it is nice and dry. The new gauge is installed. So the tank, it is ready to go. That said, though, we can't quite install it yet because we don't have the proper clearance. We need to elevate the tank by at least 1/2 inch. So to do that, I picked up this 3/4 inch square tubing. So all we need to do is cut it to size, and we can use this as a spacer to get the clearance that we need. All right, we got two pieces out of the same size. And you can see they fit just about perfect. So I am going to drill one hole. We'll put it back, find where the other one needs to be, and then we'll do the same for the other side. All right, perfect. That is the right size hole. All right, let's see how close we are. Now these holes I drilled exactly the same size as the bolts. So if the alignment is even just a little bit off, we might have to egg the hole out a little bit. I think we might be good. Let's see if they tighten down. Okay, perfect. I think this is going to work out. So I'm just going to make another one just like this. We'll get a little bit of paint on them. And then I think we'll be ready to put this thing fully back together. So the big question here is, will this stay together long enough to get to its rated load of 5,500 watts? That is what we're going to find out. Okay, so it started, although I do hear a little bit of an odd noise sometimes in the engine, so I'm not too confident about this. We are starting at about 7% THD, which isn't bad, and the sine wave doesn't look great, but that is typical on these models. So let's start with a 2500 watt load. So we'll put on 2000 watts. Actually, the voltage gauge is pegged. See that? Yeah, that's not right. So let me try 1000 watts. You can see that voltage is shooting way up. So we might have a problem with the AVR. Yeah, 145 volts, that is not good. So let me cool down the power bank, and then we'll shut it down. Interesting, the AVR just pulled out. The capacitor is 360 microfarad. Usually they're 470. I'm not sure I've seen one different on a generator this size, so that could be the issue. I do have this other AVR here, and this capacitor is rated at 470 microfarad. So let's plug this one in, see if it makes it any better. Let's try this again. I've got the end cover off, but the different AVR in there with the capacitor rating that I usually see on machines like this. So I'm hoping that it will work a little bit better than the one we just pulled out. I wish I put the camera down here because we just let out the magic smoke. So I guess the question is it the AVR or is it the stator? So let's get the AVR off and take a look. But it does smell pretty bad. AVR actually looks okay. So I'm thinking the stator just failed. It's hard to tell. I mean, I don't see where the magic smoke left from. It's not hot. So yeah, I don't know if it was the AVR that failed or the stator, or maybe something else. So, we could run some more tests, but at this point, this is more a science experiment than anything else. The rotor, despite being repaired, if you can call it that, you know, the rotor's no good. The resistance value is still too high, and I can't sell this to someone knowing what's been done to it. Really, I was just hoping to see if it would hold together for a load test, and I think the answer is no. But let's put the old AVR back on. We'll turn it back on, see if smoke continues to pour out, in which case we know for sure that the stator is done. We'll try this one last time, and I think this will be the last time. So the original AVR is back on. You know, that one wasn't behaving either, but based on what we just saw, I'm thinking it's actually the stator that's the problem and not the AVR. You know, when I first started this with this AVR, I said it sounded strange. And I guess to clarify on that, the engine kind of sounded like it was going under load a little bit, you know, for a quick second, and then the load would come off, which obviously we weren't applying a load. So that likely is just an insulation failure. So let's start it and see what we see. Well, the good news is the stator actually seems to be fine. And not only that, but when I applied 1500 watts, it maintained voltage perfectly. So I've got everything plugged back in. I've got the AVR resecured. So let's try the load test again. So let's get things reset here. Get the master switch on. Let's try 1000 watts. See what the voltage does. It seems perfect. THD at 1000 watts, 10.6%. The sine wave, it did clean up a bit. So let's turn the 1000 off. We'll do 2500. Voltage looks fine. THD jumped to 15.4. And the sine wave cleaned up a little bit more. So let's give this a couple minutes. If everything holds, we'll go for the max. And no issues at all holding the 2500 watts. You know, if anything, we could probably bring the engine speed down a little bit and maybe the voltage a touch, because it did come up a little bit. I think we started at 123 volts, it's now at 125. So let's take off the 5, swapped that for a 2. So now we're at 4,000 watts. No issues. 5,000. 5,500. It's doing it. We're at 18.7% THD. And the sine wave looks about the same. No issues pulling its rated load at 5,500 watts, so should I try for more? It's probably not a good idea, but let's try it real quick. 6,000 watts. Yeah, it's kind of out of power, so we're back to 5,500. But I've seen all I need to. You know, the engine can pull its weight, and so can the generator. Well, guys, that's pretty much a wrap. You know, going into this, I didn't know where we were going to end up, but I did know I didn't have any extra generators, so I was hoping this one would be an easy fix, like a new set of brushes or a new AVR. And as it turns out, you know, we had a broken wire on the rotor, and that is something I usually don't fix. I used to, but I never felt good about it, and I never sold the machines for more than scrap. And this one, well, even though it works, you know, my confidence is not very high. In fact, it's so low that I had the fire extinguisher right over there because I was pretty sure we were going to have to use it, and we almost did. You know, the voltage problems certainly aren't boosting my confidence in this at all. It was really odd initially when we put a load on and the volts jumped to 300 volts. So that is not normal. And then of course we plugged this AVR in and it immediately let the magic smoke out. So that might be due to the fact that we had the wrong capacitor. But this was also pulled off a parts machine. So I don't know if it was any good. And if it was good, it's certainly not good now. And the really odd thing is that by putting the original AVR back in, we now have perfect control over the voltage. So, you know, my best guess is that maybe one of these pins wasn't making good contact. You know, 2 of these pins are used for sensing the voltage and making adjustments to the power going to the brushes. And if those connections are not making contact, then the default behavior by the AVR is to go high voltage. You know, in some cases up to 170 volts. You know, in this case, I'm thinking we just had a high resistance connection and it wasn't able to accurately sense the output of the machine. Anyway, at the end of the day, you know, I set out to get this working and to pull its rated load, and that's what it did. So, I hope this video helps someone. Thanks for watching.